All right, so question, what is an angle? I'm just going to stand up and demonstrate this. So here I am facing you. I've just rotated. I'm not facing you anymore, nor am I now. Oh, I'm facing you again. I just did one rotation. So an angle is related to a rotation. And then we have different ways of measuring that rotation. So let's look at some of those different ways of measuring the rotation. So what is an angle? An angle is a measurement of a rotation. And I don't know if you're wondering, why does he have a circle here when he's talking about angles? Well, in order to measure and have a rotation, you must rotate around some point. So often we have some central point here that we rotate around. The center of rotation is often fixed, but it doesn't have to be. So we know we can throw something into the air and it can fly through space and spin at the same time. When it's spinning around some central axis of its own, its center of mass. Now, we're just looking at a much more simple version of an angle than, the center of mass of a moving object that's rotating. But bottom line is an angle is a measure of rotation. So when I talk about, say, a right angle, as an example, a right angle is equal to 1/4 of a full rotation. Now, we often talk about angles with respect to degrees, and I want to question that paradigm. So we might say a right angle, 1/4 of a rotation, is also 90 degrees. And one full rotation, we say, is 360 degrees. But here's my question to you. Why 360 degrees? Why not treat it like a percentage and say rotation is 100%, like 100? Why can't 100 degrees be a full turn? Why 360? Think about that for a second. Why 360? What's important about 360 in reality that we would choose it to measure angles? And it turns out it's kind of an accident in a way. It's related to the number of days in a year, the rotation of the Earth spinning around the sun with the sun as the center. So there are 365 days in a year. But 360 was picked because more numbers divide into it, since it has more divisors. There's really nothing all that special about 360. It was kind of an arbitrary pick. On this planet, we happen to have 365 days. What the heck is a day? Well, a day is that other rotation of the Earth on its own axis. So the combination of the Earth's rotation around its own axis and the Earth's revolutions around the sun is where the idea of 360 came from instead of 365. And no, it's really 365 1/4, and actually it's just a little less than 1/4, but that's okay. So problem, 360 is kind of an arbitrary value, and it turns out it is not the best way to measure degrees. What is the best way? Sorry, measure angles. Degrees is not the best choice. So we will use degrees in this class occasionally, just because you came in familiar with the idea of degrees, but we're going to use a different idea. And that different idea is related to the unit circle and coincidentally all other circles. So the circle I have drawn here, you might notice, has a radius of 1. Since the radius is 1, that makes this a unit circle. There are many unit circles centered all over the place. This one happens to be centered at the origin, so I like to call it the unit circle because it has a radius of 1 and it has a center. That is the origin of our coordinate system. Now, if we think about this circle of radius 1, we can find its circumference. So the circumference of this circle formula, we have two of those. One of them is just take pi multiplied by the diameter. Since the diameter is twice the radius, we can also take pi times twice the radius, but we usually write that as 2 pi times the radius. So the circumference of this particular circle, because it has a radius of 1, right, the distance around this sucker, if I start here and walk around, and I finally stop right where I started, the distance I've traveled there is again going to be 2 pi times 1, which is just 2 pi. So this circle right here has a circumference of exactly 2 pi, whether I'm measuring by feet or centimeters or miles or kilometers, doesn't matter. It's 2 pi, whatever the unit of the radius is. 2 pi is the distance once around. Now, if we pick a different circle, so let's make a new page. So we start here with a particular circle, and that's, say, a radius of 1. And then we make another circle, same center outside of that. And let's say that one there has a radius of 2. And then let's do another one just for fun out here. Might as well use 3. So I have 3 concentric circles. Say that one has a radius of 3. So the inner circle, right, let's think about this for a second. Radius versus circumference here. Radius is 1, circumference is 2 pi. Circumference is 2 pi times the radius, right? So the next one with a radius of 2 is 2 pi times 2, or 4 pi. And the next one after that is what, radius of 3. So 2 pi times 3 would be 6 pi. So the new measurement of angle I want to talk about here, and you may have seen this before, is the idea of a radian. And what a radian does is it counts radiuses. I think they're supposed to be called radii. We'll go with it. Now, think about that for a second. So 2 pi was really 2 pi times 1, where 1 was the radius. So as I move around this inner circle here, starting right there, as I go around, I'm going to cover how many ones? 2.5 of those ones. Sorry, 2 pi of those ones. Pi is 3.14-ish. 2 pi would be 6.28-ish. So that means as I count around here, I'm going to use 1, 2, 3, 4, 5. Oops, I went too far on that one. 5 is going to be around there. 6 is going to be around there. And then there's this little tiny chunk of a radius left. So keep in mind that 2 pi is approximately 6.28. For any circumference of a circle, we have 2 pi times the radius, which is approximately 6.28 times the radius. So if I use the radius as a measuring stick, as my counter, as I move around any circle, I'm going to go around 6 radiuses fully and then just 0.28 of a radius, no matter what the radius is. So if we count radiuses as we move around a circle, that's what a radian is. And a radian is the common measure for angles in trigonometry. The best way. And I believe most of you are going to go on to calculus, and it turns out you cannot really do calculus well without radian measure with trigonometry. So I'm going to extend this to calculus and beyond. So we have this idea of radians that's super important. So let's take a look. Let's see, is this circle clean enough to continue on? Now let's pick a new one. All right, so let's start with this one right here. Again, this is a unit circle, and I'm just going to pick a few points on this unit circle and mark them. So I would recommend drawing a unit circle at home right now. Doesn't have to be perfect, it just has to look kind of like a circle, and I would recommend having a coordinate system going through it, centered at the center of the circle. Now, we start measuring angles at the positive x value. So this is our reference line for measuring angles. And when we measure angles in trig, positive is counterclockwise. So positive angle is counterclockwise. So if I pick up here as where I'm going to rotate to, so I started down here and then I rotate up to there, right? And that point right there, we talked about that earlier, that's a quarter of a revolution. We could also call that 90 degrees, right? It's 1/4 of a revolution. Now, radian measure-wise, a radian all the way around, a full revolution is 2 pi. So I've gone 1/4 of 2 pi. 1/4 of 2 pi is half pi, or pi over 2. If we rotate a little farther, so again, we start with our reference line and we rotate all the way to that point over there. We're used to calling that 180 degrees. I could call it 1/2 of a rotation. Since 2 pi is a full rotation, right, the circumference of the unit circle, it's got to be half of 2 pi, which would be pi radians. Keep going. Starting at our reference here, if we were to go around in a negative direction, so clockwise, right, I could say that angle down there is negative 90 degrees. I'm going to skip talking about rotations for a minute, or at least writing them down. 90 degrees is pi over 2 radians, so negative 90 degrees must be negative pi over 2 radians, which we usually abbreviate RAD. And you might notice on some calculators, if you haven't seen trig stuff before, let's pick the Desmos Scientific, which looks a lot like many handheld scientific calculators. There's a button here to switch from degrees to rads. Those aren't rads, those are radians. So when you see RAD, think and say radian, right? So I can switch between them on that calculator. So RAD is the abbreviation for radian. And what I need you to get used to is, you might think 90 degrees when you see a right angle, but now I need you to think pi over 2 when you see a right angle. When you see a straight angle, 180 degrees, I need you to think pi radians. And instead of 360 degrees, so if I'm at this point right here, I can refer to the angle related to that point in many different ways, actually. I could say that's 0 degrees. I could also say that's 360 degrees. I could say it's 0 radians to get there, or I could say it is 2 pi radians gets me to the same spot. So one thing about angles is there are many ways to describe a particular point in a rotation. So let's refer to this one down here. A moment ago, I described getting to this point right here as a negative angle, rotating clockwise pi over 2 radians. I could have gotten to that point a different way. I could have gone counterclockwise, positive measure for an angle, right? That's positive angle. This one right here is a negative angle. And I went 3/4 of the way around. So just note 3/4 of 2 pi, 2 goes into 4 twice. So it would be 3 pi over 2 when I clean that up. So this point right here is also 3 pi over 2 radians. Now, am I saying that negative pi over 2 is the same number as 3 pi over 2 radians? Sorry, is negative pi over 2 equal to 3 pi over 2? Absolutely not. You plug those in the calculator, you're going to get two different numbers. However, if we think about those numbers as being a measure of rotation, they both take us to the same point on the plane. So getting to a point on the plane by naming an angle measurement is not a unique thing. When I talk about X and Y as a coordinate system, there's a unique way to say get to the point 1, 1. That's it. Go to the point 1, 1. When you talk about an angle, you could go clockwise, you can go counterclockwise. You could also go around more than once. So to get to this point right here, I could decide to go around completely, keep going, and then get there that way. So this green angle here is positive because I went around counterclockwise. Thinking about radians, I went around 2 pi and then another 3/4 of 2 pi. So for that green angle there, let's see, what do I have? I have 2 pi plus 3 pi over 2. So altogether, what does that give me? Let's do a little arithmetic here. We're going to multiply by 2 over 2, 4 pi plus 3 pi. So this angle to get to that point right there is also 7 pi over 2. I could have used degrees to talk about that also. I could have gone 270 degrees. That would put me at this point also. I could have gone around 360 plus 270 to get to that. So again, thing about these angles here is there are many angles we can choose that will all get us to the same point, and we could list these angles all day long. And again, there's going to be some homework problems on that to help you get used to that. When we talk about an angle in standard position is about this reference line I'm talking about and the idea of going counterclockwise. We also have the idea of what's called a reference angle. So let's talk about that next. So a reference angle is thinking about some fixed center. We're going to call it the origin here, and then some rotation. And I'm going to use, again, the idea of a circle. So let's make believe that's the unit circle to the best of my artistic ability at the moment, which is a little lacking. And we start out in standard position here and we rotate, and let's say I'm going to go get that angle right there. And I'm going to name that angle in a couple of different ways. Pen out here. So what I was attempting to do there is, if you think about degrees for a moment, I was thinking about going out 30 degrees and then 60 and then 90 and then 120, and then over here would be 150. If I keep counting over here, that would be 180, right? So let's write down some relatives of 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees. So in this case, I'm counting by 30 and I work my way around. So that's right here. So one way to reference this angle right here is 150-degree angle. So next, we're going to try and think about this in terms of radians. And then we'll get to the reference angle. So again, you got to get used to radians, which means you really should write them down often. And sometimes it's nice to have it on a piece of paper. So I know that 90 degrees is the same. We calculated that earlier. That is pi over 2 radians. How did I get that? Well, the whole distance around, right, we call that one revolution, which is also 360 degrees, is the circumference of the unit circle, which is 1 times 2 pi, which is 2 pi radians. So that's all the way around. I want a quarter of the way around, right? So if I'm thinking about 90 degrees, that means that's a quarter of the 360. So that would be 2 pi over 4 radians, which reduces to pi over 2. Okay, so you need to get that memorized, that pi over 2 radians is 90 degrees. Now, in this quadrant, in this first quadrant here, 30 degrees is 1/3 of the way to 90. So 30 degrees must be 1/3 of 90 degrees, or pi over 2. And if you clean that up right there, you get pi over 6. So this one right here is pi over 6. If you go another 30 degrees, that gets you to 60. That means go another pi over 6. So 60 degrees must be 2 of those pi over 6s, which is going to give you pi over 3. So that one right there is pi over 3, which is 2 pi over 6. That's okay too, but we like to reduce it. This one right here would be 3 pi over 6s, right? That's the pi over 2. This one right here would be 4 pi over 6s. So earlier, you should have noticed I was counting by 30. Now I'm counting by pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which you might say, hey, we could reduce that. We will in a minute. This would be 5 pi over 6. And this right here would be 6 pi over 6. And if you're anything like me, one of my favorite things to do in math is cancel stuff. So we would just say, hey, that's pi. And again, radians versus degrees. 5 pi over 6 doesn't reduce, it's just 5 pi over 6. Unless we want to throw it into a calculator, then it's not exact anymore. 4 pi over 6, right? We can divide 2 into the 4 and the 6. So I could call this 2 pi over 3. Now that makes sense to me if I look back over here, in that I know that the 60 degrees is 1 pi over 3. So 120 should be 2 pi over 3s, right? 1 pi over 3 to here, 2 pi over 3s to there. So a new thing to get used to, you can easily count by 30, 60, 90, 120, 150. Now we're going to grow our brains a little and we're going to learn to do things like count by pi over 6 or count by pi over 2. And there's going to be a few other special ones that we're going to look at. Now back to reference angles. The reference angle is the one closest to the x-axis. So although I said this was 5 pi over 6 on 150 degrees, its reference angle would be the remainder to get to the x-axis over here. And so I could either say that that is 30 degrees, or I could say that it is pi over 6 radians. And that right there is the reference angle. So a reference angle is to the closest part of the x-axis. All right, let's do one more reference angle here and we will move on. Let's suppose that I measured my angle, new color, coming around, round. I'm going to stop over here. I'm going to stick with the pi over 6 theme and talk about how we measure that particular angle right there. So if I come around here, I am pi over 6 away from the y-axis there, but reference angles are about x-axis. Now I went 1, 2, 3, 4, 5, 6 pi over 6s to get here. 7 would take me here. So this one right here must be 8 pi over 6 to get all the way around to there. And you can see the 8 pi over 6, I could clean that up. Again, how did I get 8 pi over 6? Starting here, 1, 2, 3, 4, 5, 6, 7, 8. Top and bottom divide. So I could call that 4 pi over 3 for the measurement of that angle in radians. That's the actual standard angle, positive measurement. If I want to do the reference angle for that sucker right there, then I'd want to say, well, what's the angle to get to the x-axis there? And that would be 2 pi over 6s. So the reference angle for this one right here would be 2 pi over 6, which is really pi over 3. Right? I'm just looking at my drawing, counting back 1, 2. Reference angle, we always keep it positive. And you should keep in mind what quadrant you're in. You should be quadrant aware in this class. So again, remember this is quadrant 1, quadrant 2, quadrant 3. So the angle 4 pi over 3 is in quadrant 3 and has a reference angle of pi over 3. So again, reference angle, closest part of the x-axis.